A 26-year-old man comes to the physician for genetic counseling. He is planning on having children soon and wishes to assess their risk for inheriting his condition. He stands 132 centimeters, 4 feet 4 inches tall, and has proportionally an enlarged head and shorter limbs compared to other adults. His father, mother, wife, and siblings do not share any phenotypic expression of his condition. Which of the following is the most likely chance that this patient will have a son who inherits his condition? Choice A, 0%, Choice B, 25%, Choice C, 50%, Choice D, 67%, or Choice E, 100%. I'll wait 5 seconds and answer the question. So this patient has achondroplasia, which is an autosomal dominant condition because of a problem in the fibroblast growth factor receptor FGFR3 gene, which leads to impaired chondrocyte proliferation and differentiation, leads to impaired long bone formation, which is why you have the short stature and proportionally large head compared to shorter limbs. Obviously, in this case, we're more concerned about the fact that it's an autosomal dominant condition. The only weird thing in this question you might notice is that both his father and his mother do not have the condition. So he likely has a de novo mutation that causes achondroplasia, which is actually the most common way you see achondroplasia in real life. But what you need to know is that it doesn't matter if he got the condition through a de novo mutation. When he has children, he's still going to pass it on in an autosomal dominant manner. So we have likely a heterozygous male in the patient and a wife who does not have the condition, so she is homozygous for not having the condition. And we know the patient is heterozygous because a homozygous mutation in FGFR3 would likely be fatal in utero. So for an autosomal dominant condition with one heterozygous parent and one parent who is homozygous for not having the condition, the odds of having a child who inherits the condition is 50%. But the question also asks specifically for a son, so that's another 50%. So 50% times 50% is choice B, 25%. Obviously, that last bit about a son might be seen as kind of an asshole way of writing a question on my part, but a lot of practice questions love doing this sort of thing, so you just gotta read carefully. So let's just go through the wrong answer choices here. Just real quick, choice C, 50%, we already know that's wrong because that's the odds of them having a child in general that has achondroplasia, but not specifically a son. Choice A, 0%. Usually when this comes up as the correct answer choice, it's because they're asking you about a mitochondrial disease and the patient is male. You just gotta remember that mitochondrial diseases is mom passes it to all her kids, and guys do not pass it on. So if a guy has mitochondrial disease like ragged red fibers or whatever, MRF, the odds of him having children with the disease is 0%. Mitochondrial DNA comes from the mom. Choice D, 67%. This is one of those percentages that you'll see pretty often in genetics questions because they love asking about the odds of being a carrier for an autosomal recessive condition. Because if somebody is asking about being a carrier, then you already know that they're not affected. So the most likely scenario is that they have two parents who are heterozygous, and they'll probably mention in the question that they have a sibling that has the condition. And then the patient is asking about what are the odds of me being a carrier. Well, since you already eliminate the possibility of being homozygous for a condition, little a, then you know that the only possibilities left are big A, which is 1 out of the 3 chances left over, and the other 2 of the 3 chances left over are big A, heterozygous, which means carrier. So 2 out of 3 would be 67%. They love for you to know that, and they like trapping students who didn't study genetics, and they mistakenly pick 50% because they don't discount the possibility of being homozygous for the condition. Anyway, choice E, 100%. This is similar to choice A in that usually when this comes up, it's talking about a mitochondrial disease. But of course, instead you would be talking about a female parent passing it on to all her kids. The only other thing I can think of is the odds of inheriting an autosomal dominant trait from 2 parents that both have it. Basic genetic stuff, right? So bring it back. Obviously you want to know how to calculate these annoying percentages for genetics questions, but random fact you gotta know is that if you have a de novo mutation, then from then on it doesn't matter that they had it from a de novo mutation, they're still going to pass it on in the same way you typically think of it, whether it's autosomal dominant, autosomal recessive, whatever. And of course, remember to read these genetics questions carefully, because they like throwing you curveballs, like asking you, what are the odds of them having a son? Instead of asking you about what are the odds of having a child. I hope you found this video helpful. I'll see you in the next one.